On to Gwen for our lightning talk session on Shiny for Sharing. Take it away, Gwen.
Hi, everyone. We're so glad to see you here. And we're glad that, even though it's a Friday afternoon, we have a lot of attendees and it's, close to the last day and last session. So I'm really, really excited to hear what these presenters have to offer. So Alexis, I think you're our first presenter. So she's going to be talking about connecting experts to the data using our Shiny to improve child welfare in Tennessee. So, Alexis, are you ready to go? Yes, we're ready for you. Do you want to share screens?
Yes, I think I'm sharing. Can you see okay?
I can see your screen and I can hear your voice, and I'm really excited to hear about your project in Tennessee.
Great. Well, thank you so much for having me. My name is Alexis Fleming. I am a PhD candidate at Vanderbilt University Biostatistics, and I'm really excited to tell you about what I've been working on. So, connecting experts to the data using our Shiny to improve child welfare in Tennessee. I'm going to start the presentation by giving some background, some context, talking about who our stakeholders are, what is a CANS assessment, and where is the data coming from, and then move into the actual Shiny app demonstration. So talking about how do you provide access to your stakeholders, how do you create tables, and this is really the innovative part of the Shiny app is this table creation. And then I'm going to touch on some heat maps as well. So for context, I am a part of Vanderbilt University Department of Biostatistics, but my team works with the Vanderbilt University Medical Center, Center of Excellence for Children in State Custody, the longest name ever. And they have some consultants on their team who work with the Tennessee Department of Children's Services, DCS. And so the Tennessee DCS is who actually works with the children and takes them in custody and talks to them, places them, does all the things. And then there are consultants who work for the Vanderbilt University Medical Center, COE, who consult the DCS on children's needs, their strengths, how to meet those needs, all of the above. And so those are our stakeholders, and they use the Child and Adolescent Needs and Strengths, the CANS assessment, which is a national assessment used to check out where are children's needs, where are their strengths, how can we help them out, make their lives better. And so our data for this is a combination of this CANS assessment data as well as the placement data. So when a child enters custody, where are they actually being placed? There could be multiple placements when they come into custody, depending on what their needs are at the time versus over time, how can we differently meet those needs? How do the needs change? And then custody data as well. So without further ado, I'm going to move to the CANS Shiny app and say, so that we don't breach any data, I'm not sharing the key here. I've already submitted it, so the data is already loaded. But typically, when we share this app with someone, we will also secure, which is just a link to a website, we will securely send them a key. And that's how our stakeholders have access to this data, have access to this Shiny app. And so we use RedCap Send It. You can use any method to securely send your key, your access. But Shiny app offers this great way of putting in a key, pressing submit. We have encrypted data on here. It handles all of that, loads it into this app. Works really well for, especially for PHI data that a lot of us are working with. So once you enter the key, push submit, a little box pops up that says your key has been submitted, the data is loading. And then they have the options to move to these tables. Now, as I was saying, the tables are the meat of this presentation because previously, before this Shiny app, the people who are actually working with the children, and then also those people at DCS who are working with the lawmakers and the judges and the people who are actually able to make a change, meet children's needs, are the ones who really need to see how they're doing, how this data looks. But they would have to go through a really long system of figuring out what they need to see, taking it into a form that we're going to understand and explaining it to us, the data people. And then we have to try and make sure that we understand what it is that they want before we move to the making the tables, giving it back to them, which ended up with a pages and pages and pages long PDF of different tables, different plots, all the things that would just get sent out periodically. And I'm talking at least 40 pages of a PDF. You might be scrolling tens of pages to find the one table that you requested. So we realized that is not working. The requests just keep coming. How can we make this better for everyone so that we are actually meeting children's needs and actually showing the lawmakers the data so that they can make actionable changes? So we're here, we're at the tables tab. And this is where we're making a difference right here. The lawmakers, the DCS people, the consultants, everyone are able to come into this if they have the key and say, I want to look at fiscal year 24, which is the one that I'm focused on right now in all of my data analysis. And I am in the West region. So this is the state, this is the part of the state of Tennessee that I'm focused on, that I care about. And I want to see how many 5 through 12-year-old children are in the child welfare adjudication status. Oh, 215 children that I need to be focused on, that I care about. Wow, there's 4 5 through 12-year-olds. If anyone knows anything about children's custody, JJ stands for juvenile justice. I would not want a 5 through 12-year-old in my juvenile justice system. So if I were someone looking at this data who actually works with these children and is able to make a change, I would say, I want to look at these four children here in my area from last year. And so they're able to really look at the data, exactly what they want to see. So say like we don't want to look at adjudication status, we want to look at gender. How many 5 through 12-year-olds are female in our data? 114 in my region, in the West region. And then we can take it even a step further and actually group the tables, which is a huge, huge difference from a PDF, right? Of looking at just one table and not being able to change anything. So this is the really, really interactive portion. Say I want to look at this by quarter. I want to see in my fiscal year, I made a change in quarter one. How is that reflected in quarter four? So this is really interactive, really helpful. I would highly recommend using Shiny apps to make interactive tables for those people who you want to see your data. And then the best part is you can download it. They're getting it right into Excel. Nobody needs to copy paste anything. Nobody needs to take screenshots. It's already right in there for what they want to do. And lastly, making a plot. As we all know, anyone who doesn't stare at data every day, plots are so, so, so helpful. So this also, being able to create and download interactive plots, amazing, wonderful. I would highly recommend. Last thing I want to add while we're talking about plots is heat maps in Shiny app are so, so helpful and amazing. I would highly recommend trying these out, using them in your own personal work experience, anything, because these have been a game changer for us for being able to hover, select, change the heat maps. For some reason, this really gets across to people. So I would recommend trying heat maps in Shiny app. And that's everything I wanted to touch on for today. So thank you so much for having me. Again, here's my email, contact information. If anyone would like to reach out, I would love to talk to you about it. And thank you again for having me.
Thank you, Alexis. We really appreciated your talk. Vanderbilt's is such a special place. I wonder if you're, I just wonder if you're at the Dolly Parton Center. Isn't there Dolly Parton's gave a whole bunch of
There is, yeah. My
Who-
sister named her chicken after Dolly Parton after coming to Nashville. So
That's a great thing. Anyway, I think we'll leave questions till later, and we'll go on to the our Spanish cohort, R for Shiny for the visualization of large multi-source data sets and data integration use cases of Spanish tourism statistics. And I guess it's I want to guess that you're are you from Barcelona? Am I right?
Almost. I'm from Valencia,
You're from
from the
Valencia.
south,
Okay. So I
a
don't
bit
know if
northern.
it's Jordi. Is it Jordi? So is that a
It's
Catalan name? Yeah.
yes, yes,
Jordi Verdu Naranjo, or is it Naranjo?
naranjo.
Is it Naranjo?
Yes,
Okay, I thought that. Okay, I get confused between which part. So that must be a Spanish last name and a
yes,
Catalan
exactly.
first
A
name.
bit complicated, but yes, it's like that.
Anyway, whatever. Okay, so can
Okay,
you share slides? We're really excited to hear
okay.
about about how you're using Shiny in Spain. So thank you.
Okay. Can you see the presentation?
Yes, sir.
Okay. So anyway, I'll start. Hello everyone, I'm Jordi Verdú from the methodology unit at Spain, and I will present to you the work that we made for visualizing large multi-source tourism datasets. Our work was part of the MNO Mind project at Europe, the aim of which was to explore different techniques to utilize mobile network data in order to improve official statistics. In our case, our work was focused specifically in enhancing the estimation of tourism-related aggregates. So in order to do this, we had a large amount of different data sources, which involved, for example, the MNO data itself, which was provided to us by the three main telephone operators in Spain. And this data consisted in aggregated counts of SIM cards, putting SIM cards in this case. Additionally, we also had survey data, which consisted in it basically provided us with additional tourism-related variables, which allowed us to link the administrative data and MNO data together in order to convert that information into interesting variables related to tourism. And finally, we also had administrative data, which consisted on information related to the entries and exits to the borders of Spain. So what do we do with these datasets? Well, the thing is that all of them are a extremely valuable information source, but they pose two major challenges when performing an exploratory data analysis. First, the high granularity of our data makes it difficult to properly explore all the data space. And additionally, the large volume of this data, especially in the case of border entries and exits and MNO data, made it not only made it that required extremely powerful hardware to edit and run these datasets, but it also usually caused a lot of slowdowns when plotting and testing with this data. Fortunately, R has a wide range of tools to help us with this task. Specifically, Tiny allows us to build UIs which can help us extremely in order to streamline visualization. And most importantly, in our case, the arrow package was the most important element because due to the size of our dataset, we needed to work with Parquet datasets. This allows us to only load the specific part that we need of a dataset in order to visualize or edit in any way we need it. So the following schematic describes the internal structure of our dashboard in a simplified manner. Basically, every different data source required a specific UI and server, so it was mandatory to split them into self-contained modules, where the source application script calls all of the other scripts and instantiates each UI and server for each data source, and then builds them together into a complete application. However, it is better to show than to tell, so I will now show you a short demo of our application. And it should be highlighted that all shown data in this presentation has been randomly generated due to confidentiality issues. I cannot share all the data with you. So I will run the application. You can see the screen, right? Okay, so this is
Yes,
the
we can
introduction
see
page.
it.
Okay, thank you. So this is the introduction page, which is done with the leaflet package, this interactive map, which represents the location of the administrative data collecting points, basically, like, for example, black dots signal airports and blue dots signal ports. All the other regions basically are road regions. However, let us move on to a more interactive tab, for example, selecting the road section, the loop tab. This is a great example of how complicated it can be to properly examine a high granularity data set, because we have a lot of variables that we can select and filter. For example, the date range, the vehicle type in this case, the aggregation in time level, and even we can select the different regions here and filter and select by Vasco. And as we can see here, we can filter the loops that we wish to see. We can select them again, and we can also check the different chart types. For example, we can see the total amount of counts detected per loop on the selected regions and loops, or the total amount of cars detected in the entire border space. Additionally, this dataset had a particular issue where there was a large amount of missing data, so we did perform some imputation experiments using LSTM neural network. I can load the imputed data clicking this button. As we can see, the imputation was done on the daily level, and we signal each imputed day with a red outline. And if we select a higher aggregation like month, we can visualize the proportion of imputed data by changing the alpha level or transparency of the different parts that each one represents. I will move on to the MNO section, to the MNO tab. It's also a relevant section. In this case, the initial plot that we are greeted with is the distribution of SIM card counts. This distribution is dependent on the nationality of the SIM card that has been detected. And we can also select a different date range and even the different telephone company. We can also select them all, and so we can compare their distribution together. Additionally, it's also possible to visualize losing the aggregation by nationality, but we gain the time information of this data, so we can see the evolution in time of the data. Finally, I'd like to show you the map section, in which we represent the proportion of tourists normalized to the population of each region. These numbers don't make sense because they are randomly generated, but this page, this tab was done using the tmap library, and in this case, it was essential to use the Parquet library because, for example, I'm not going to show you because it's going to take a little bit, but the municipality aggregation level, the entire dataset was around, it needed around 100 gigabytes of RAM in order to completely load it and edit it. And so by using the Parquet, by using the Parquet datasets, we can get an extremely fast loading and plotting in real time, basically. And this map in particular was extremely helpful to properly understand what happened, the underlying issues that MNO data itself had, basically. Because there are, for example, border effects that may distort the amount or the number of counts that we have near border regions, for example, near Portugal. Unfortunately, I don't have much more time to show you the dashboard, but I would like to say as a conclusion that it was extremely helpful to properly understand our data and to select a decent or a correct integration algorithm. So moving back to the presentation, it is a short list of references that I have used to build the application. And that's all. Thank you for listening, and I hope you have a nice day.
Thank you, Jordi. We appreciate you. I really liked your application. I thought it was really wonderful. So thanks for sharing it with us. Okay, Axel, we have you next. It's the economic indicator analysis tool. So if we could move on, and we'll take questions at the end. Thanks.
Awesome. Can you all see my screen?
Yes.
Great. Hi, my name is Axel. I work in the Economic Indicators Division at the US Census Bureau, and today I'd like to share how our team has been able to leverage Shiny to innovate our analysis of US economic indicators. Chief mission of the Economic Indicators Division is to provide the public with periodic insights across the US economy with data retrieved from surveys and administrative reports. These data have several use cases. For example, the Bureau of Economic Analysis used some of these data for estimates of the nation's gross domestic product. Um, Private businesses may also use these data to help measure market share. I specifically work on publishing retail trade data, which uses data from both the Advanced Monthly Retail Trade Survey and the Monthly Retail Trade Survey. With the fast-moving pace of surveys, especially monthly surveys, a tool that can provide on-demand insights is critical. Also, having a tool that has all indicators accessible in one central place will help us a lot with quicker cross-indicator analyses. And that brings us to our main objective, developing an awesome dashboard with dynamic visualizations and giving us kind of quick insights into the trends we want to look at. And we figured that Shiny is an excellent tool to help perform and achieve this goal. To develop our application, we created an R Shiny app script that retrieves the latest indicator data from the Census API. That script would then tailor raw data into more interpretable and desired metrics. For example, we use tidyverse functions to create additional columns for monthly, quarterly, and annual trends. And then using that tailored data, we took advantage of Shiny's user interface functions to help build a very user-friendly application designed to showcase the key analyses we were most interested in. Let's take a look at that Shiny app. When run, users are given a drop-down menu to select from data from 25 different US economic indicators, and it defaults to the Advanced Monthly Retail Trade Survey, which I mentioned earlier, I work on, and a little bit biased towards. After an indicator is selected, users can perform a similar selection for industry. So in this case, the user is interested in US restaurant data. So they would select for industry NAICS 722, which is food services and drinking places. This will provide users with data specific to that selected industry, with trend visualizations and an interactive table of selected data. Users can further customize how data is visualized with the option to toggle from a line graph to a bar graph, selecting whatever color they may be interested in, and as well as selecting date breaks to kind of hone in on kind of specific time periods that they're interested in. Users can select an additional industry to kind of cross industry analysis within an indicator. A common comparison to restaurants is grocery stores. So users can select NAICS 4451 grocery stores and kind of see exactly how those trends align to each other. And similarly, they could kind of toy around with what colors they might want to be make each indicator, make each industry. As I mentioned earlier, users can view their data of interest in an interactive table. This could be queried down even further. For example, if users are interested in the latest data, so May 2025, searching -05 in the search column in the search section will provide data just for the month of May for both NAICS 722 and NAICS 445. Users also have the option at the bottom to export these graphs into any way of their choosing. They could just copy exactly what they see in the table, or they could select to download a CSV or an Excel, as we're often interested in kind of dragging over the data into an Excel file and kind of manipulating it to our liking even further. Thank you so much for your time. I would also like to mention, in addition for helping out with our analysis, this project has been an awesome way to introduce and get a lot of our analysts involved with open source tools like R. And last but not least, please check out our economic indicators. Thank you so much.
Thank you, Axel. Randall, I think you're next. A Shiny app for linked micro maps.
Okay.
Randall, are you sharing screen or?
I'm working on it, yeah.
Okay. If there's anything we can do, let us know.
Okay, do you see my
I
screen?
see everything. Yep, and I can hear you too.
Okay. So thanks everyone. Today I'll discuss a project to create an R-Shiny tool that harnesses linked micromap concepts and functions available in the Micromap ST package. This app provides an improved user experience.
Oh, wait.
So,
I'm sorry, Randall, I'm going to jump in. I think you're on your very last slide and not the first one.
oh, okay. So
Thank
there's
you, Wendy.
You're welcome.
thanks, Wendy. So there's So in this presentation, I'll discuss current methods of visually displaying state-level geographic data, introduce you to a possible improved way of doing that using linked micromaps and the Micromap ST package, discuss limitations presented by the current package, and introduce an R-Shiny application I'm working on that seeks to improve the user's experience. So what are some current ways we display state-indexed data? This is a default bar chart from Excel showing the American Community Survey response rates for 2022. They're ordered alphabetically by state. The default axis labeling in this case is such that every other bar is labeled, so we lose half of the state names. It's hard to extract useful information from this plot. So here we're ordering by the variable of interest. We can see the states with the maximum and minimum response rates, but we gain nothing regarding geography. We can't tell anything about response rate across geographic regions. So sometimes data is presented in a table, often ordered alphabetically by state. Again, this method of data presentation makes it difficult as a user has to make the mental comparison of data across the rows and columns of the table and sometimes skipping across pages. So chloropleth maps are commonly used to display geographic data. In these maps, the color indicates some quantity. An advantage of using chloropleth maps is that people are familiar with them. However, there are some disadvantages, and we'll discuss some in a motivational example where BLS data is published as a chloropleth map that we think can be shown better using micromaps. So you're probably asking yourself, what is a linked micromap? Linked micromaps were developed to display geographically indexed statistics in an intuitive way by linking them to a sequence of small maps. The approach integrates several visualization design principles such as small multiples, discrete color indexing, and ordering. Linked micromaps allow for other types of data displays that are connected to geography, including scatter plots, box plots, time series plots, confidence intervals, and more. And I should say that I'm not the one that developed this package, but I think between Wendy and Martinez and I, we can probably answer a lot of questions if there are any. So this is an example of a linked micromap produced using the Micromap ST package. The first column shows US states with highlighted regions. The second column is the legend. To the right are one or more columns showing statistics in various displays, such as dots as shown here. Geographic regions are organized into perceptual groups. 51 states which fit well. There's a median state, and there are 25 states above and 25 below in groups of 5. Compare that to a bar graph with 51 bars, or a line graph with 51 lines, which are too cluttered, making it difficult to understand what is going on. Or a chloropleth map, where you wouldn't have this kind of sorting ability. So now we're going to take a look at an example using BLS data. So the BLS Quarterly Census of Employment and Wages releases quarterly state-level data for numerous industries, both for employment and wages. The BLS website has an app that allows us to choose the industry and what statistic we want to display, which is rendered in a chloropleth map. Here we see 4 chloropleth maps at different points in time for the 12-month change in employment variable during the COVID-19 pandemic. To tell a story with the data over time, we have to piece together multiple maps with different legend color thresholds. Now let's see what we can do with the same data using the Micromap ST package. We see that Micromaps gives us more information about rank ordering of the states at the start of the pandemic and how the leisure and hospitality industry behaved during COVID. So this is just one of several examples that I presented at the Joint Statistical Meetings in 2024 in an effort to bring more attention to the benefits of using the Micromap ST package. Having used it a bit myself, I found one of the shortcomings was the learning curve when it came to the programming. Certain inputs are required, such as number of data columns, and others are optional, such as axes labels or map titles, and must be programmed in a specific order. It's not readily apparent how to do this until you really dig into the documentation. Plus, we're doing exploratory data analysis, and being able to change things easily via GUI is essential. Also, you can't view results in RStudio. You have to create and save a file and then view it outside of RStudio. So I said, well, maybe this could be improved and made more user-friendly if I developed the Shiny app that integrates these functions. So I set about to create an application that will alleviate these issues and allow the package user a simpler and quicker way of harnessing the benefits of the package. So the user I'll do a little demo here. I won't demo it live, but I'm using screenshots instead. The user chooses a data frame that is in their working space that contains the input data they want to explore. They then choose how many columns they wish the micromap to have, 3, 4, or 5. The first two being the required columns, then the additional columns with the desired statistical visuals. They then enter the various titles and column labels, as well as choosing which type of graphs they wish to display and which variables to use. While this does take a basic level of understanding of the outputs and how they are determined by the user inputs, it's far easier to enter in a Shiny app and have the app doing much of the thinking for you than trying to create the program from scratch. So once the user puts all the inputs in, they can play around with things and see the results of their play in real time in the app. Whereas without the app, they have to run the function each time and go to their local drive and open the results, and then rinse and repeat by trial and error until they have what they want. Whereas using the application, they can do all the trial and error in real time and produce the actual file only after being sure they have what they want. So the app is not quite done. I plan to add box plot and time series capabilities, and probably a few other tweaks. So the programming for both of the box plots and time series require additional inputs, and unsurprisingly, integrating into the app is a little bit trickier. So after that's all done, then it may be time to create a package and make the app available to you, the public. And if you happen to be at JSM in Nashville this year, look for my recorded talk at an invited session on Monday at JSM. So thank you for listening. And if you have any questions, comments, suggestions, please feel free to reach out. Thank you.
Thanks, Randall. I'll just say that JSM is Joint Statistical Meetings for those people that might not be familiar with that acronym. But anyway, I'm going to try and pronounce your name, and you're going to correct me if I do it wrong. It's Redwane Betroni. Did I say it kind of right?
It's red one, but no E. So that was the whole reason why initially I had red and then number one. But today I chose to rename it Red One. It's a French spelling of an Arabic name. It's crazy.
Oh, okay. Okay.
It's this one. It's also Persian, Indian, I mean, all of the above.
Right. Does it have a meaning or not?
Satisfaction or happiness.
Oh, that's thank you. Thank you.
Oh,
So we're looking forward to your talk, Enhancing Etchy Signum Framework Usability with a graphical interface. So thank you.
Thanks for attending. So this is my talk. So basically, the story started by there's a dedicated package to analyze doing inference modeling of multivariate time series developed by our colleague at the Census Bureau, Tucker McElroy. So the idea was, can't we make like a package, not a package, an R-Shiny app to make life easy for users? And the answer is yes. So little disclaimer, the views here are not necessarily of the Census Bureau, are mine. So I'm gonna do the demo. So I'm gonna share with you. I mean, there's a lot of things. We started scratching the surface, but I'm gonna start by. I mean, I can do it from here. So this is running behind the background. So the demo start like this. We upload the data file. It could be CSV. For now, it's CSV to make life easy. And for the purpose of this presentation, I'm uploading the famous, popular airline time series data. It's univariate, but just to show you the utilities. It has 3 columns. X is the original data set. It has a star. This is the metadata associated with it. You do take the log, and we see an upper trend, and there's you might think there's seasonality because of this pattern over time. And to answer this question, if we do Fourier transformation spectral decomposition of the time series, this graph will help the analyst to determine, yes, there's some seasons. In fact, they are exactly 1, 2, 3, 4, 5. And then we continue to do the, I guess the word is feature engineering if you are a machine learning person, or create more explanatory variables if you are a traditional statistician. And then TD is for trading days. Easter is regressors, is one of the regressors. For the model construction, we fitted, I mean, there's a lot of functionalities in this package, but one of them is the RIGA ARIMA. So you have the RAG, which is multiple linear regression, but not randomized, it's deterministic. And then once you have this fit, we do an ARIMA model on the residual. So this is the mathematical equation behind all this mess. The MLE estimation, because of the time, I would like to switch to one of the utilities is to, when we have missing data. And this is an example where your time series, especially if you have a multivariate time series, we might have one of switching from, I guess, sampling frequency month to quarter, quarter to month, things might change. So we might have missing. And people know about forecasting, predicting the future, but you'll be surprised. Sometimes you would like to forecast, not a mid-cast. So this is a term that was coined by my colleague Tucker. So for the spectral analysis, it wasn't meant to work when you have missing data. So we do our modeling. I'm just rerunning this model construction. Now for the maximum likelihood estimation, because of the purpose of doing this demo, I'm not gonna run the MLE estimate maximum likelihood, but I'm just gonna copy because I saved the fit. Control A, Control C, Control V. So this is the log likelihood value, and then this is the Hessian eigenvalues. And the analyst, of course, we always do this, the residual plot, to see whether we have heteroseducticity, if we need to transform one of our variables. And this is the ACF, the autocorrelation function. The model, I guess the data is happy with the model. I mean, this is, our data is monthly. It's 12 times 12, 144 data points. And this is year, so it's not, it looks good. And then this is what I want to show you. So the midcast imputation. So basically, we can decide on doing this prediction and then display the 95 95% confidence interval. And then we can download this output as a CSV file or JSON. So again, we just start scratching the surface, and the idea is to convert the entire package into a user-friendly app. I think I want to show you the Excel file quickly. So this is the original values that we had missing, and then now this is the imputed value. I think it's worth mentioning that the entire thing is available in GitHub, and the name of the repo is SSG Signum _ GUI. So the original package is SSG Signum developed by our colleague Tucker, and _ GUI is the. I think that's all I have. So I'm gonna hopefully I can leave some time for questions for me and other colleagues. Thank you.
Thank you so much. The first thing I wanted to ask everyone is if you could put the link to the coding, all of your coding, if it's available on GitHub anyplace, can everyone put their link in the chat so that we can all peruse your coding and reuse it. So there were a couple questions in chat. Let me, oh, it looks like they were answered. For Axel. I'm sorry. Yeah, no, I said your name right, Axel. So, Axel, I don't know if you want to answer those live, or if you want to go through that.
Sure. So I think one of the questions was adding a new indicator data product to the Shiny app, and the answer is I will definitely consider that and meet with that team specifically. And the second one is just adding like non-seasonally adjusted data and as well as other metrics to the app. And yeah, I think I definitely agree that would be awesome, and we'll definitely consider adding to that. And I will try to see if we could add our GitLab code to make it shareable.
And Redwan, I hope I said that right.
Yes, you did.
Oh, good.
So I saw Peter Meyer question. So yes, so the answer is yes and no. So the original package by Tucker has it, all functionalities, and the current app, it doesn't produce that. But I mean, the possibilities are endless. Thanks for this question. All kind of hypothesis testing and whatnot.
So I think we have a little bit more time. I don't know if anyone has any, I have questions to ask, but I feel like I just want to give other people the opportunity to ask, questions to maybe each other. If anyone wants to ask anything of anyone in the other panel. Oh, wait. And then Lisa had a question that she reached out to me about, which was about who uses this. How many people use your the extent to which that your dashboards get used, and how they may be modified based on user input. So if we could go through that, or if there's any other questions for anyone that anyone else wants to ask to anyone else on the panel.
I'm sorry, can you repeat that question? Was it meant to me or all the presenters?
It was for all presenters. So if you have a question for another presenter, you can ask that. But Lisa had a general question, which was how often do your dashboards get used, and how can they be modified based on user input?
So I can tell you something from I know we have colleagues at the Census Bureau where they have this, actually it's the population division, population estimate projections. They have this, it's a GUI, it's like a super GUI in the web. And they have data about how many users, and there's always these questions. But this is something to consider. I mean, I guess it's possible, but this is something to consider for any app in the future. And maybe, I mean, the end goal is why not create a Shiny app for every package out there? Why not create a package that will just take a package as an input and then create a Shiny app? Or maybe it turns into, this is more like, especially for data analysis and modeling for the analyst, make it more like, what's the word? It's more like a Power BI tool, a dashboard. I think that's the correct.
Alexis, I wondered if you could tell us a little bit about how much use your app gets. Does it get a lot of use or?
Yeah, so it depends on the day. Some days, especially, towards the end of a fiscal year, a quarter, or anything, it could get a lot more. Or if there's a lawsuit going on, like there is right now in Tennessee, it also gets a lot more use for that. So it can see up to 40 or 50 logins a day or like keys submitted. And we're actually working with Posit right now because they offer specific licenses for Shiny app servers. And so if anyone knows more about that or would want to share more, we're working on that right now because you can base it on how many users you get.
Okay, thanks for that. Did I freeze or did Alexis freeze? Does anyone know? I guess I didn't.
I think Alexis froze, Gwen.
Okay, good.
Oops.
We heard you though. I think mostly you just wanted contact from people. Okay.
Yeah, just if you know anything about the Posit Shiny app servers and want to share, we're working on getting licensing through them so that more people can access the app.
Okay. I think that's it. Thank you very much to everyone. I do have more questions, but I think we're already 2 minutes over and we need to go on to this next panel discussion. So thank you again to all the speakers, and I was really impressed by everything, and I still would like access to code if you are willing to share it.
So thank you very much for